The half-bridge-based modular multi-level converter is the state-of-the-art building block for HVDC. Typical HV-MMC contains unipolar submodules with simple topologies but lack DC fault blocking capabilities. The potential protection technologies include the use of fault-tolerant converters, AC side circuit breakers, and DC circuit breakers. However, the first two options have limitations. The costs and power losses of fault-tolerant converters are high, and AC side circuit breakers operations are too slow for DC fault protection. Also, use of DC breaker for HVDC protection needs further investigation. Mechanical breakers are slow because they need additional commutation circuits to achieve zero current crossing. Solid-state breakers with power electronics switches are fast, but this comes at the expense of high conduction losses. The most promising solution is a hybrid DC breaker, which integrates a fast mechanical breaker with a semiconductor branch and an energy absorption branch. The commercial hybrid DC breaker are under testing stage. Let's look at the operation of hybrid DC breaker. In the closed position, current flows through mechanical breaker, and when a fault happens, the current will be communicated to the secondary branch by switching off the mechanical breaker and then be absorbed by the arrestors after switching off the solid-state breakers. My objective was to implement the hybrid DC breakers control function in a DSP controller and to interface it with a benchmark HVDC system implemented in a real-time digital simulator. The HVDC system with DC breakers is simulated in RTDS. The DSP board interfaced with RTDS via digital and analog GPIO cards runs the program for breaker controller. At each time step, the DSP controller receives the current measurements from RTDS analog outputs and decides the next state. Then the DSP controller delivers the switch control signals to the DC circuit breaker via RTDS digital inputs. The plot from RTDS shows how the circuit breaker deals with a permanent fault. Circuit breaker do open, delay, and reclose operations for 3 times and be opened permanently. And if the fault is clear during the operation, the breaker would reclose to normal operation. The plot shows fault current limitation operation. It allows the circuit breaker to limit the DC fault current in a predefined range by switching on and off the main breaker. If the fault is cleared during the operation, the FCL will stop and the breaker will reclose.